penuh bermisi guru AYU, mencapai misi yang satu, permisi kita bantu.
Tahniah. Siaran langsung ini dibawakan khas kepada anda oleh Akademi YouTuber Malaysia. Tumpukan perhatian anda. Siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Assalamualaikum. Good evening and hi to all teachers, parents and the wonderful students. So welcome to Pusat Tuisyen YouTuber, a joint venture with EDD Malaysia and Kelab Guru Malaysia with the hashtag Bermula Percuma, Selamanya Percuma. Initially free and forever free. So before we proceed, let's begin our session with the recitation of Kitab Al-Fatihah. And for the non-Muslim, please take a moment of silence. Okay, so how is everyone doing today? My prayer is that everyone is in the best of health and ready to proceed with today's class. Let me introduce myself. I am Madam Rosmaya from SMJK Yuhua, Kajang, Selangor. And today I will present alone because Madam Don cannot be with us today. Before we start our discussion today, please subscribe to my channel so that you won't miss any of my new video in the future. As usual, the lesson will last approximately for 1 hour. The certificate link will be given at the end of this lesson. You can only use EDD email and MOE email to claim the certificate. I will put the link now in the chat box. Okay, done. So be sure to follow the class up until the end and give your full cooperation in making this lesson a lively one. So I would also like to remind students to use appropriate language if you wish to post comments in the chat box. I'm pretty sure all of the students here are excellent students who will uphold a positive classroom environment. So stay focused, and if you have any questions, please write in the chat box. So now I'm going to open my slide. Okay. Let me introduce the pre-U teams that we have in the Academy YouTuber. Okay, so these are physics pre-use team collaboration with Stpm teachers and matriculation teachers. So our members in physics Academy YouTuber is Teacher Su, Teacher Apsayu and Teacher Non. Okay, next we have also Maths team in Academy YouTuber lead by Teacher Im. Okay, Biology Pre-U team lead by Cikgu Faiza. Chemistry Pre-U team lead by Cikgu Shahnun. And also we have Perakaunan and Ekonomi Pre-U team lead by Madam Fizi. Okay, Academy YouTuber also has apps where you can download it from Google Play Store, and there are a lot of videos there, including the physics videos. Okay, so now we have come to the main objective for today's live class. Okay, tuition class. So what is our learning objective for today? So we are going to do revision on chapter 7, statics, topic statics, chapter 8, deformation of solids, and chapter 9, kinetic theory of gases. So we combine 3 chapters in one. Okay, so in the link for the question, I given already one day earlier in the description part, and I post in the chat box already. Okay, so the statics formula in topic statics, the formula that we are going to use is this formula. So if the object move, if the object is in equilibrium, okay, there are two formula we use here. Statics mean the object is in equilibrium, the system in equilibrium. If the total, we can use total of fx, okay, all the forces along x equals to 0, or total of forces along y equals to 0. Or you can also use total of force at the right side equals to total of force at the left side. Or another one is total of force upward direction equals to total of force in the downward direction. So either one you use. But if you want to use the middle one, so you need to take into account the sign direction, positive and negative. Okay, usually positive to the right and negative to the left. And for the vertical direction, positive is upward and negative is downward. But if you use the left, this equation, okay, right equals to the left, up equals to down, so we don't bother about the sign. Okay, for clockwise direction is positive, and anti-clockwise, counterclockwise direction is positive, and clockwise direction is negative. So you can use either one. For the total of torque equals to 0, or counterclockwise counterclockwise equals to the total of torque clockwise direction. Okay, so let's look at question number 1. Okay, so a light rod is hinged at an angle of 30 degrees to the horizontal and is kept at equilibrium by the force Fy and Fx. Okay, is shown in the diagram below. Okay, so this is the diagram. So if Fy is 200 Newton, what is Fx? So most of the question here is from the past year question, okay, or trial question. Okay, so this question one is from Stpm question. Okay, so how we do? We use use only rotational equilibrium, which is total of torque equals to 0. Okay, so let's say we use clockwise moment equals to counterclockwise moment. So moment formula is force time perpendicular distance to the force. Okay, so for clockwise moment is Fy. Okay, Fy. So how you know? We determine all the forces that act on the rod first. Okay, so the rod is mentioned there, light rod. So that's mean the weight of the rod we don't take into account on the forces here. Only we have Fy and Fx given by the question. So we can ignore the weight of the rod because mentioned there light rod. Okay, so if Fy, if we choose the fixed point at the position here, okay, so the Fy will move in the clockwise direction. If just consider the Fy alone, so the rod will move in the clockwise moment, clockwise direction. And for Fx, again, this is a fixed point. So the Fx, when we apply the Fx alone on the rod, so it will move in the counterclockwise direction this way. Okay, so that's why we put like this, clockwise moment on the left side and counterclockwise moment on the right side. Okay, so this is the fixed point chose. Very important to determine the fixed point because we are going to measure the direction from the point applied. So for Fy, the perpendicular distance from the fixed point is L cos 30 degrees. So we use trigonometric ratio. So Fy is, you see, perpendicular to the distance L cos 30 degrees. So L cos 30 degrees, we substitute into here. So force time distance, the moment formula is force time perpendicular distance. So Fy times L cos 30 degrees. So for Fx, the perpendicular distance is L sine 30 degrees. So Fx times L sine 30 degrees, we can cancel out L. So that's why L not given in the question. So we don't use the L. So we cancel out L and we rearrange the equation like this. Fy is given 200, so we are going to find fx. So 200 equals to fx sine 30 degrees per cos 30 degrees, and sine per cos is tangent, tangent 30 degrees. So fx we get 346 Newton. So the answer is D. Okay, hopefully you have done the question. So those who've done the question and got the answer D, congratulations. Okay, so the correct answer is D. Okay, now we go to question 2. Okay, so those who are with me today, live tuition class, can write something there to say so that I can know who are here today. Hi. Okay, now we go to question 2. Okay, there are altogether 15 questions we are going to discuss. So question 2, we read the question first. Three forces, each with a magnitude of F, and then F, we to have two F's here and two F. 2F on the right, left side, F, right side. Act on the spherical object of center O, are shown in the diagram below. So which statement is true about the spherical object? Okay, so which one? A, the spherical object moves with a linear acceleration. B, the spherical object moves to the left and then stops. C, the spherical object is stationary. And D, the spherical object rotates. So look at the forces act on the spherical object here. So we use if you use translational equilibrium, you see that F here, we only consider the horizontal forces because this F and the 2F is in horizontal, so we don't bother about the there is no vertical forces. So this F on the right side is 2F, right direction 2F, and on the left direction 2F is left direction and F is on the right direction. So F plus F equals to 2F. So that means they are balanced. To both equals in magnitude. Both is 2F. So that means they are equilibrium in the direction horizontal direction. No motion in the horizontal. No horizontal motion. Okay. So now we try the rotational equilibrium. So we choose fixed point in the middle. So I used to use the formula total of torque equals to 0, but this time, okay, I'm going to use this equation instead. Okay, clockwise moment equals to counterclockwise moment. So for clockwise moment, will be this F, this F. Okay, so the fixed point we choose at O. So this F we rotate to in clockwise direction. O is the fixed point. So for this F, okay, also move this F will move in the counterclockwise moment if we choose O as a fixed point. So 2F we don't use because 2F is already in the at the fixed point. So no rotation if at the force is on the fixed point because the distance is 0 measured from there. Fixed point is where we measured the distance from. So 2F is at the fixed point, so the reading will be the distance measurement from here will be 0. Okay, so only this F. So that means this F perpendicular distance will be R, radius of the spherical object, R. The other one for counterclockwise, this F will give counterclockwise direction if applied to the spherical object. So the perpendicular distance measured from the center of the spherical object also R. So that means they are balanced. Both has the same magnitude, Fr. So that means no rotational equilibrium. In other words, the total of torque is 0. Correct, it is 0. Okay, so that's mean the spherical object is stationary. So that's the answer. Okay, so those who get answer C, okay, congratulations to you all. Okay, so now we go to question 3. Okay, question 3. Okay, a diver of weight 500 Newton. Okay, this question also is a STPM question. Okay, a diver of weight 500 Newton stands on the free end of a uniform springboard of length 2 meter. Okay, 1.5 plus 0.5 will give you 2 meter. So the length of the board is 2 meter as shown in the diagram below. So two supports X and Y. Okay, so we have X and Y supports distance of 0.5 meter from each other. So to enable the system to be in static equilibrium. So if the weight of the springboard is 200 Newton, what are the magnitudes and directions of the reaction force X on the board by X and Y? So first step, we determine the forces that act on the object, on the board here. So we have weight of the diver, which is 500 Newton, reaction by X and reaction by Y. Don't forget one more, the weight of the springboard, the weight of the springboard. Okay, so 500 Newton acting downward because the weight of the springboard is 200 Newton. Okay, given also act downward. Reaction by Y, support Y will build upward. Let's say we name this as RY. And reaction by support X will be downward, Rx. Okay, so reaction by the two surface, board and the support X. Okay, so now which the questions one reaction force by X and by Y. So that's mean we are going to determine Rx and Ry. Okay. So we use rotational equilibrium, and we need to use both rotational equilibrium and translational equilibrium. So we do rotational equilibrium first. For rotational equilibrium, let's say this time we use this method. Total of torque equals to 0. We didn't use clockwise moment equals to counterclockwise moment. So if we use this one, okay, let's say fixed point we choose at X so that the distance will be 0 measured from this point, the fixed point. So in the equation that we are going to form, we'll only have one variable. So we can find that variable because we have only one variable. So the formula, remember, force time distance. Okay, for Rx, you didn't put here also can because it is at the fixed point will be 0 times Rx will be 0. So I just purposely put here so that you can see why we didn't actually no need to put it there. So 0. Okay, for Ry, this Ry, the distance from the fixed point is 0.5. And it's a positive because it's counterclockwise direction. Okay, so if you put the whole talk on the right side, so you need to put the sign together. Bring along the sign together with the force time distance. The formula of torque is force time distance. So Ry times 0.5 is positive because clockwise direction. Next is 200. So 200, the what we call this the springboard. Okay, so the springboard mentioned there uniform. So it has meaning there. Why it put uniform there? Because we know that the weight of the board will act in the middle, in the middle of the board. So the board is 2 meter length, so that's mean 200 Newton times the perpendicular distance will be half of this 2 meter measured from the end here. So that's mean it's 1, and it's negative distance is 1 meter. That's why uniform there is mentioned. So we know that 200 Newton must be in the middle of the board, springboard. And negative because it's clockwise direction. Okay. Then the last one is the weight of the diver. So 500 and 500 is negative because it's a clockwise direction. Okay, clockwise direction, so negative. And the distance is 2 meter, because the diver is at the other end of the springboard. So 2 meter, the length of the board is 2 meter. Okay, or you can use the clockwise, these two you bring to the right side also can. Okay, so now we solve for Ry, we get 2,400 Newton. So now the answer for Ry is this one. We don't know yet, either C or D. Okay, 2,400 Newton. So C or D. Next, we uh, do for translational equilibrium to find Rx. So for translational equilibrium, because all the forces here, you can see they are in vertical direction, so we don't use the horizontal or forces along X. We don't have here forces along X, so we take the vertical forces only, so we total them up. Upward direction only Ry, so Ry will be positive and the Rx will be negative. Okay, because upward direction Rx Ry positive 2,400 Newton because upward direction, then 200 is negative. Okay, another one is 500 there. I hope you all can see the writing quite small there. Okay, very clear. Okay, so minus for downward direction, plus for upward direction. Ry is positive. Rx, we don't know the value yet. So Rx is what we are going to find. So no need to put the sign, whether it's positive or negative. So at the end, we can get that Rx is negative. So it shows that Rx is downward direction. You can guess actually. If Ry is upward, Rx will be downward. So the answer is D. Negative stand for downward. Okay, so that's the answer. Question 3. Okay, Chia Yao. Okay, I can see you write there. What you write there? Okay, now we go to question 4. Okay, question 4. Okay, question 4 is I got this question from the trial. Okay. Okay, trial exam. So we read the question. A 5-meter long ladder is resting on a smooth vertical wall with its lower end 3 meter from the wall. So drawn here and mentioned there, 3 meter from the wall. What should be the coefficient of friction between the ladder and the floor for equilibrium? Okay, so which one is the answer? Okay, this will form a right angle triangle, so that's mean OA will give you 4 meter, reading 4 meter. So 3, 4, 5. Okay, use Pythagoras theorem. Okay, so we determine all the forces. The forces will be normal from the wall. The wall is smooth. The wall is smooth, so that's mean this is normal reaction vertically acting from the wall. From the wall. And then we have weight of the ladder. It act because the ladder doesn't mention is we consider the ladder is a uniform, so that's mean the weight of the ladder acts in the middle. Okay, downward. So if this 5 meter, so that's mean the distance from A is 2.5 meter and distance from B also 2.5 meter. Okay, then we have reaction by the floor, by the mention there by the floor. Okay, reaction by the floor is we name as RB. Okay, reaction by the floor, and reaction by the floor. There are two components because the questions one coefficient of friction. So we resolve the component of reaction by the flow into two, RBY and RBX. Okay, RBY is vertical reaction and RBX is horizontal reaction. Okay, RBY is equals to the normal of the normal force. and the RBX will be friction. Okay, friction. So these two component will combine together, becomes the reaction by the points B on the floor. Okay, so friction is equals to mu r. So we can get coefficient of friction by this friction. Mu n mu nb. So this nb, okay, mu nb. So this is friction formula, mu nb. N is normal force, normal force. Okay, so now we have determined all the forces. Then the fixed point we are going to choose is at A. Okay, you can choose at anywhere, but depends on what the questions wants. The questions want coefficient of friction, so we don't know NA. We don't know NA, so we choose fixed point at A so that NA times the distance will be zero. Zero because we don't know NA. We are going to find mu, which is coefficient of friction. Okay, so now we are going to use the formula translational equilibrium. Total of fx equals to 0 or total of fy equals to 0. Another one is rotational equilibrium, total of torque equals to 0. Okay, for the translational equilibrium, so we need both. We need both. So for translational equilibrium, okay, look at the translational equilibrium. So now we can ignore RB. We just use RBY and RBX. Because RBY and RBX is the resolved vector from RB. Okay, so NB equals to W. Okay, so NB is upward, W is downward. So NA not involved because it's horizontal. Horizontal. So the vertical forces are weight and NB. So NB equals to weight. Okay. So now we form another equation from rotational equilibrium. So from rotational equilibrium, okay, we choose fixed point here. Okay, so NA will be 0. No need to put it also can. Okay, no need to write down here also can because it's at NA is at the fixed point. Okay, now W we take the component W cos theta because it's perpendicular to the 2.5. So we take the component W cos theta. W can be resolved into two components. So we choose component W cos theta because its perpendicular distance is 2.5 along the ladder, or another word is 5.2. Okay, this one I delete first. Okay, 5.2. So W cos theta is the force that perpendicular to the distance 2.5 or 5.2. Okay, lastly is the force NB. Friction. Friction. NB is vertical already, so we choose FR. So FR is already perpendicular to the distance 4. So we can straight away use this 4 times FR. Okay, look at the 4 measured from the fixed point. 4 is perpendicular to the FR. Okay, so FR times 4. So and we total them up is equals to 0. And the sign is negative for the clockwise direction and positive for the counterclockwise direction. So this W cos theta will make the ladder move in a, look at the direction, so will move in the clockwise direction. So that's why negative. And then NB, this NB will make the ladder move in a counterclockwise direction. So positive. And lastly, NB I didn't mention just now. NB, the perpendicular distance from the fixed point is 3. Okay, 3. So 3 horizontal, NB is vertical, right? You see, so NB is perpendicular to the distance 3D. So that's why NB times 3. Okay. Lastly is friction. Friction is will make the ladder move in a clockwise direction. So that's why it's negative. Okay. So now we've checked all the sign and the distance for each of the forces. Then we solve. So this one 0. So W is NB given by the equation 1 here, the first equation from translational equilibrium. So we can substitute NB into here, W. W is NB. Okay, cos theta times 5 per 2 and then plus NB times 3 minus FR, friction. FR stands for friction. So friction is mu N. So mu NB times the distance 4 equals to 0. Okay, so now we can cancel all NB. So now the variable that we only don't know here is mu, mu. So we can solve for mu. Cos theta, okay, theta we can calculate using trigonometric ratio. So cos theta is opposite per adjacent, okay. Adjacent per hypotenuse. So cos theta is adjacent per hypotenuse. So adjacent is 3, hypotenuse is 5. So we substitute 3 over 5 there. Okay, 5 per 2 and then plus 3 minus mu 4 or 4 mu. So mu is 3 per 8. The answer is B, 3 per 8. Okay, so hopefully you can understand the question, how to answer this, the solution here given. Okay, now we go to question 5. Okay, question 5 is the STPM question. Okay, STPM question. So the figure below shows a picture frame hanging from a string. So which of the following is the graph of tension T in the string against angle theta? So we first determine the forces that act on the picture here, on picture frame. So we have T, okay, and then we have weight of the picture frame. Then we resolve the component of T becomes T cos theta and T sin theta. Another string here also, we resolve the component. So T cos theta and T sin theta. Okay, first step, determine all the forces. Second step, we use the formula. So for translational equilibrium, we use the translational equilibrium formula. Total along Fx is 0 and total of forces along Y is 0. So we take the total along Fy equals to 0. So T sin theta upward direction. Another one also T sin theta. The green colored green there, colored blue. So total them up and minus mg because downward direction. So equals to 0. So T sin theta plus T sin theta is 2 sin theta equals to mg. So we get T equals to mg 2 sin theta. So mg is constant because it's the weight of the picture frame. 2 also a constant value. So you can see that T is as T increasing, theta decreasing. So the possible graph is D, D. Okay, so T and theta is inversely proportional to each other. Okay, for the horizontal forces, look at the direction of T cos theta and T cos theta here. So they are opposite direction, so they are balanced, balanced. So you cannot, it doesn't, the picture frame is also static along the X horizontal direction. So we can see from the first equation here, along Y for to determine the graph for the correct graph. Okay, the answer is D. Okay, now we go to question 6. Okay, for next question involve the next topic, the formation of solid, chapter 8. Chapter 8. So we are going to use the formula for stress, force over area, strain, extension divided by original length. So E is Young modulus. Young modulus equals to stress over strain. So we substitute these two into here, we get FL per EA. Then strain energy, half force time extension. And then from the graph stress against strain, we will get area under the graph equals to the strain energy per unit volume. Okay? So be careful with this one. For stress strain graph, we will get area under the graph as strain energy per unit volume. So the shape here is a shape of a triangle. So that's mean area of the graph is half times stress times strain. Okay, area of a triangle. Okay, now we go to question 6 for topic 8. Okay, we read the question. A uniform metal rod of length L, a cross-sectional area A, and the Young modulus E are acted by a tensile force F. So the strain energy stored in the rod is represented by, okay, so you are given L, A, E, and the tensile force F. Okay, you are going to find strain energy. So the strain energy formula is half Fe. So the problem here, E is not given. So in the answer here also no E, right? So we need to find E first. To find E, we can use Young modulus. Okay. So Young modulus is stress over strain. Okay. So stress is force over area and strain is extension over L. So we get FL per EA. So E is FL per EA. Extension is FL per EA. So you substitute into the strain energy formula. So simplify, we get F squared L per 2 EA. Okay, so the answer is which one? The answer is D. D. Okay, answer is D. Okay, now we go to question 7. Okay, question 7. Two steel wires P and Q were suspended from the ceiling with each wire being stretched by a weight W. If the original length of wire P and Q are 2L and L respectively, and both wires have the same extension, so what is the ratio diameter of wire P and diameter of wire Q? So we have two length is 2L, another length is L. Then diameter of wire P and diameter of wire Q. Okay. So from the formula Young modulus, stress over strain. Stress is force over area and strain is extension over L. So we get this formula for Young modulus Flea. I love to memorize this as Flea. FL per EA. Okay, so now area of the wire, cross-sectional area will be pi r squared, area of a circle by r squared. So because we are going to relate with diameter, so r is d per 4, so becomes pi d squared per 4. So we rearrange the equation here for FL per E pi d squared. Okay, so we cross multiply. We get that diameter of wire DD. E is a constant because it's the same wire. Extension will be the same, so the difference is the length. The rest is the same. The force act on them also the same. So that's mean D is D squared is directly proportional to L. So you can form two equations, or you can use straight away ratio method. If you form two equation and then use ratio, you cancel out the same value, like extension E, pi, and for also F. So we just use this method. D squared is directly proportional to L. So that means the equations become D1 squared per D2 squared equals to L1 per L2. Okay, then we substitute 2L and L. L1 is 2L and L2 is L. So we can cancel the L. And for ratio D1 diameter wire P to diameter wire Q, that means D1 over D2 is square root of 2. Okay, so the answer is D. C. D no square root for number 2. So C, the answer is C. Okay, so that's the answer. Next we go to question 8. Question 8. Okay, question 8. Okay, we read the question first. The figure below shows an extension against force graph when a wire is stretched to point P by a force F which increases gradually. So when the force is reduced gradually, the wire returns to point Q. So which of the shaded regions below shows the recovered energy from the process? Okay, be careful what the questions want. The questions want recovered energy, not and not energy loss. So many confused with this two. Recovered energy, not energy loss. So another one is be careful with the question, the graph given, whether it's a fx graph or xf graph. So this is xf graph. So area under the graph is the work done for fx graph for both. So which area, you compare these two. So for the fx graph, the area will be below. For the xf graph, the area will be on top of the graph, of the graph. So this one is xf, so that's mean the answer is B. So the recovered energy is from this line drawn. Okay. For C, this one is energy loss. C is the energy loss. So the answer is B. So be careful what the questions want. Okay, now we go to question 9. Question 9. Okay, question 9 is kinetic theory of gases. Chapter 9 is now we entering chapter 9. Okay, kinetic theory of gases for STPM semester 1. So I've put all the formulas into one slide here for this chapter. Okay, for the pressure, so for 1/3 density times the mean square speed. Mean square speed. So another two formula is 1/3. N is number of molecules per unit volume. M is mass of one molecule. Remember this M is mass of a molecule. Mean square speed 1/3. Number of molecules, capital letter N stand for number of molecules per volume, and mean square speed. Okay, for the RMS speed, we can derive this from the mean transnational kinetic energy. Okay, so RMS speed is square root of mean square speed. Okay, we get square root of 3 kT per m. K is a Boltzmann constant. T is absolute temperature in Kelvin. M is mass of a molecule. Okay, or we can use Boltzmann Boltzmann constant K equals to R per Avogadro number. Then this mass for Avogadro number, we get molar mass. Capital letter M here is molar mass. So be careful with this M. So it's very easy to memorize because K small letter, M also small letter, R capital letter, so M also molar mass capital letter. Okay, then also we can use RMS formula, square root of 3 pressure per density. This one comes from this equation. So all this equation is related to each other. They are derived from this equation. Okay, this equation is PV equals to nRT. Or you can use PV equals to NKT. Here, substituting N, not normal. This N is number of mole. This one is not the same as the N here. N here is number of molecules per unit volume, but this N is number of moles. So number of mole, we can use number of molecules per Avogadro number, or mass of a gas divided by molar mass. So this M is mass of a gas, not mass of a molecule. So be careful with the M from the above equation. This M and this M. This is mass of a gas. This is mass of a one molecule. This one also mass of a one molecule. Okay. This mean transnational kinetic energy of a molecule, also mass of a molecule. This M is also mass of a molecule. So we can use formula the kinetic energy as 3 nRT per 2n, or 3 RT per 2 Avogadro number, or 3 kT per 2. Okay, so there are three formulas here. Okay, so actually 4 formulas. Only we can expand the top formula here into another sub formula. We can say that sub formulas. Okay, so let's try question 9. Okay, question 9. So I think before we start, we take a rest. We take a rest. For the before we start question 9, we go to the advertisement. Okay,
Tuisyen online
for
percuma. Tuisyen online percuma. Layari www.academyyoutuber bagi mengikuti tuisyen online secara percuma. Prasekolah, sekolah rendah, sekolah menengah, semua ada di Akademi YouTuber. Rujuk jadual di laman sesawang www.academyyoutuber.com. Semoga masa terluang anak-anak anda diisi dengan sebaiknya. Tuisyen online percuma mestilah Akademi YouTuber.
okay, welcome back. We go back to our question number 9. My slide, question number 9. Okay, we read the question first. Question 9. 20 gram of hydrogen and 24.0 gram of helium are mixed together in a container that has a volume of 0.50 meter cube. The temperature is 350 Kelvin. So calculate the number of moles of hydrogen, the number of moles of helium, the pressure inside the container, and the pressure due to the hydrogen alone. So molar mass of hydrogen and helium are given here respectively. So this is mass of hydrogen, mass of helium. So you label what the data given in the question, so that you don't make careless mistake by substituting later. So T is 350 Kelvin. So we are going to find number of moles for hydrogen. Okay, so now the another one below here, molar mass for hydrogen and molar mass for helium. So we use this equation, PV equals to nRT. So because of we are going to find number of moles, so we choose this one, PV equals to nRT. So N is M per M. We are going to find number of moles, so M is given, so we can straight away use this formula. Number of moles, mass over molar mass. So mass is 20 gram for the gas hydrogen, for the hydrogen gas, and molar mass 2. So 20 divided by 2, 10 mole. So for helium, we do the same. So it's 24 divided by 4. Okay, so first two question very easy. Okay, next for the P final, pressure. Pressure inside the container will be P final because they are mixed together. Mixed together. So wait, let's name this as pressure inside the container. So we name as P final. So for P final, we use PV equals to nRT because we calculate N already. N already. So for mixed hydrogen and helium, the N will be 10 plus 6. Then temperature given 350 and volume 0.5. Okay, so R is molar gas constant 8.31. So we get 9.3 times 10 to the power of 4 Pascal. Okay, next is pressure due to hydrogen alone. So this one is for hydrogen alone. So pressure for hydrogen alone, we can see here volume is constant. R because they are in the same container. Helium also in the hydrogen in the same container. So volume is constant. R is constant. T also constant. They are in the same container at temperature 350 Kelvin. So the P is directly proportional to the N. So N for hydrogen is different from helium, which is 10 mole. So this is at initial. So at final is considered as they mix together here. Okay, so pH per P final, we write the formula because directly proportional. So that's mean pH per P final equals to NH per total of the N, number of mole. So we substitute P, and then this one is total of number of mole 10 plus 6. So we cross multiply, we get 5.8 times 10 to the power of 4 Pascal. So this is the answer. Go back. Okay, so this is the answer. Okay, now next question. Question 10. Okay, we have 6 molecules of a gas move with speeds 450 meter per second, 400 meter per second, 500 meter per second, 550 meter per second, 450 meter per second, and 500 meter per second. So we're going to calculate mean speed and RMS speed. Okay, so for the mean speed, very simple. You just total them up divided by 6. You get 475 meter per second. So for the RMS speed, so remember the formula, square root of square of the speed, all the speed here, 400 square, all this squared divided by the number of speed given. They are altogether 6, so you get 477 meter per second. So this is average speed, this is RMS speed. So remember the formula, because we are going to use this formula again in the SEM.2, formula for the RMS speed. Okay, so next question 11. Okay, sketch the molecular speed distribution graph for a sample of gas at 300 Kelvin and 500 Kelvin, and mark the most probable speed at 300 Kelvin as V naught and at 500 Kelvin as V naught prime. Okay, for the first question, sketch the graph. Number molecular speed distribution graph is number of molecules against speed. So label the axis and also 0 there, label. And this is the graph for 300 Kelvin, and this is the graph for 500 Kelvin. So the graph is shifted to the right, to the right like this. The question also mark the V naught. Most probable speed is the highest speed there. Most probable speed mean the speed, the most of molecules is the highest there, right? So all of the gas, the highest number of gas has this speed V naught. So for the 500 Kelvin, so the number of molecules that has this speed V naught prime will be less. So you mark as the question asks with V naught prime. Okay, next, use the graph to compare the number of molecules with speed greater than the most probable speed at 300 Kelvin and 500 Kelvin. So we use area under the graph to represent the number of molecules with speed larger than V naught. This one is speed larger than V naught. Then for 500 Kelvin, the graph for 500 Kelvin is labeled with this one. Okay, purple color. Okay, this is represent the number of molecules with speed larger than V naught prime. Okay, so we compare both the area we name as A2 and A1 just now. So A2 is larger than A1. A2 is larger than 1. Okay, that's question 11. Okay, next we go to question 12. The RMS speed of an ideal gas at 27 degrees Celsius is 0.3 meter per second. So its RMS speed is 927 degrees Celsius. Okay, this is T1. This is RMS speed 0.3 second, and we're going to find the second RMS speed final. Final to represent final. So T2 represent final. So we can use this formula where RMS speed is directly proportional to square root of T. Okay, square root of T. So RMS speed is directly proportional to square root of T. So K and M is constant. 3 is a value, so it's a constant. Okay, molar mass also constant. It's a same gas. So C, RMS speed is directly proportional to square root of T. So we can form the equation C1 over C2 equals to square root of T1 over square root of T2. So you substitute this value 0.3 over C2. C2 is what we're going to find. So don't forget to convert the degree Celsius to Kelvin. If not, you don't get the answer. So you get C2 equals to 0.6. So the answer is B. Okay, the answer is B. Okay, very simple. Okay, now we go to question 13. Okay, helium gas occupies a volume of 0.04 meter cube at a pressure of 2 times 10 to the 5 Pascal and temperature 300 Kelvin. So calculate the mass of helium, the RMS speed of its molecule, and the RMS speed at 432 Kelvin when the gas is heated at constant pressure to this temperature. So you are given the relative molecular mass of helium, molar mass 4, and molar gas constant is 8.31 joule per mole per Kelvin. So this is volume, pressure, and T given. So this is the first temperature, second temperature, later will be 432 Kelvin. Okay, we are going to find mass of helium first. Okay, so the mass, we can use PV equals to nRT because we are going to find M. So number of mole is not given, so we use N equals to M per molar mass because molar mass is given. So we choose this equation. Okay, so M is PVM per RT. So combine both, we get M equals to PVM per RT. So substitute the pressure, the volume, okay, molar mass for helium 4, R and T 300 Kelvin. So you get 12.8 gram. Okay. Then RMS speed. So from these three equations, so you choose 1 per 3 rho mean square speed. So density, we can use mass over volume. Okay, density, mass over volume. So mass calculated already just now, 12.8. Okay, so you substitute into here and can find C1 squared or mean square speed equals to 3 PV per M. So substitute the P, V and M just now from A into the equation. So you square root the value here. Don't forget square root because this is mean square speed. So you square root this, you get 1370 meter per second. So round it off to 3 significant figures. Many students make mistake here in number of significant figure because in the calculator display is about 1369, but the given value here is one significant figure, three significant figure here. The largest is 3 significant figure. So to be safe, you round it off to 3 significant figures. Okay. So the last one is RMS speed. RMS speed for the next temperature 432 Kelvin. So you use the kinetic energy, okay, 3 kT equals to half m mean square speed. This one, okay, you use this one. So we can see that here mean square speed is directly proportional to temperature, or RMS, or we can use RMS lah. RMS directly proportional to square root of T also can. Okay, so either to just now we use mean square speed equals to square root of T. Okay, that one also can be used. So we take the ratio C2 mean square speed 2 over mean square speed 1 from B. Then temperature final T2 over T1. So we get RMS speed 1640. Okay, again round it off to 3 significant figures. Okay, so that's the answer for question 13. Okay, now question 14. Okay, the pressure of an ideal gas in a vessel of fixed volume is P. So if the gas in the vessel is heated so that RMS speed of the molecule is increased 3 times the initial value. So what is the new pressure of the gas? So you are given the pressure of the ideal gas. This is P initial. So we are going to find P final. RMS speed is given 3 RMS, 3 times the initial. So this of the final. So you are given RMS speed final and initial in terms of CRMS initial. Okay, so we are going to find a new pressure, the final pressure. So from this equation, so we choose this one because got volume. The question said fixed volume, so we choose this equation, and the pressure is directly proportional to the mean square speed. Volume is fixed, number of molecules also fixed. Because the gas is in the vessel, okay, contained on the vessel with fixed volume. So M also constant, the same gas. Okay, so now we can form the equation Pi per P final equals to mean square speed I per mean square speed final. So we substitute these three CRMS per okay, we use initial first on top. So CRMS per 3 CRMS. Okay, so we simplify. P is given. Here P is given, so you substitute as P there. What we are going to find is P final. So cross multiply, we get 9P. So the answer is D. D. Okay, and the last question. So the last question, what is meant by degrees of freedom of a gas molecule? So degrees of freedom refer to the number of independent ways a molecule is able to move or acquire kinetic energy. Okay, it can move in rotation motion, clockwise or anti-clockwise. Okay, rotation. And also can move up and down or left, right, or forward, backward. So it refers to the number of independent ways a molecule is able to move or acquire kinetic energy. So write an expression relating the total kinetic energy of a gas to the number of degrees of freedom F. So explain any other symbol used. So this question just say write. So you just write the formula. Kinetic energy of a gas molecule is half F kT. Okay, then the extra symbol used is Boltzmann constant K, and T is the temperature of the gas in Kelvin. Okay, so you can just write like that because the question asked right. Okay, 3, we are going to find the escape velocity from mass for oxygen. Escape velocity from mass is 5 times 10 to the 10 cube meter per second. So if the temperature of mass is 300 Kelvin, so determine whether oxygen gas can exist on the planet. So molecular mass of oxygen is 32 gram per mole. Okay, we use the formula above, half FKT. Okay, kinetic energy is equals to half mv squared. So you can find the speed of the gas oxygen, square root of 5 kT per m. So oxygen is a diatomic, so the F degree of freedom is 5. Okay, for polyatomic 6, and for the um, monoatomic is F is equal to 3. F equals to 3. So for diatomic, F equals to 5. Okay, next we substitute the Boltzmann constant, temperature given 300 Kelvin. And the M here is mass of a molecule. Be careful of this mass. So this is mass of a molecule. So we use this formula, Avogadro number, N per Na equals to M per molar mass. They are N from the number of moles equation. So N is the for one molecule, mass of a molecule. So N is one molecule, Avogadro number M, we can find mass of a one molecule, and M is the molar mass, substitute 32 into here. So cross multiply, we get 32 times 10 to the negative 3 per 6 Avogadro number lah. This one is Avogadro number. So 32 gram convert to kilogram. Don't forget to convert to kilogram. So the answer is 624 meter per second. So which is larger, smaller than 5 times 10 to the 3. So that's mean the from to compare with the 5 times 10 cube meter per second. So these oxygen molecules with speed less than this value will not escape. So it can exist on the Mars. But if the oxygen molecules have speed larger than 5 meter times 10 cube meter per second, so these oxygen molecules can escape the planet Mars. But if less than that, cannot escape. So this is the guideline. You calculate this now is 624, won't escape. Will not, can exist on the Mars. So that's the answer for question 15. Okay, so now we have come to the final question. So with God grace, we have reached the end of today's lesson. So congratulations. So I close my slide. Okay, thank you for watching. So congratulations to those who are able to follow our lesson from the beginning till the end. Okay. So all of you, please stop posting your comments for a while and click the subscribe button and activate the icon bell so that you will not miss the next class lesson. If you find that the lesson was beneficial, click like and share to your friends on your social media. Spread and share the goodness. So once completed, you type done on the chat box before the certificate link is given as a token of thank you for your dedication in joining the free online class today. So I will put the link of the certificate, copy and paste there in the chat box. Okay, so I put already there. So please take note, the link the link will end half an hour after this live. Okay, so make sure to use the EDD email and MOE email only to log in. Incorrect email will not be entertained. So if you haven't got one, you can apply the link for the EDD email already. I already put in the chat box. Okay, you can scroll up and have a look at take a look at the email EDD to apply the email EDD. So if you wish to get more information on the online classes, you go to www.academyyoutuber.com, and those who haven't joined EDD Junior Telegram, you can do so. So once again, I would like to thank all of the students for joining today. You are awesome, and feel free to share this free tuition class to your friends and teachers all over Malaysia. So this is actually the collective effort from all teachers throughout the Malaysia for all the students throughout the country. So thank you too for being a YouTuber Academy supporter too. So I think that's all for now. So see you in another lesson. Remember the hashtag bermula percuma and selamanya percuma, initially free and forever free. Assalamualaikum. Stay safe till we meet again next week, same day, same time, on Sunday at 5 p.m. Okay, so bye bye.